Hello and welcome to another video. In this video, we're going to be working on valid anagram. And in the problem, you're given two strings s and t, and you want to return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the letters exactly once. So here we have this is true and this is false. So let's write down some characteristics of an anagram. Characteristic number one, like what do we need for two words to be anagrams? They have to have the same number of characters, right? AKA like the length has to be the same. So for these two words, we can just check right away. If the lengths are different, there's no way they can be anagrams. And the other thing is, for every character, their counts have to be the same. Right, so if we take the word anagram, for example, if we just count up the characters, so we have A3, then we have G1, then M1, N1, and R1. And so that's 7. Okay. And for this other one, if we take a look for this Nagaram, this will be exactly the same, right? We have 3 A's, 1 G, 1 M, 1 R, and 1 N. So what you could do, one of the typical ways is you compare anagrams, is you make a dictionary of anagrams. And what we're actually going to do, instead of making two dictionaries, we're going to do something else. So first we're going to check for the lengths. And then what we are going to do is, for when we go through it the first time, we will write down these numbers. And then when we go through it the second time, we will actually subtract. So like in here, for every character, we'll add a 1. And then in here, for every character, we'll subtract a 1. So in the end, these should all be 0. And assuming they are all the same length, what's going to happen here, if they're not an anagram, is some of these will be positives and some of these will be negative. If they are the same length, that means you can't have, like, you're never going to have something like this, right? The total is going to stay 0, but because you will essentially add 7 all the way down somewhere, and then you'll subtract 7. I know this is a little unclear, so like I said, if you want to, you could just make two dictionaries for each one, and then compare key by key, but this is like a little shortcut you could use to just have one dictionary where first you add, then you subtract, and then basically if they are an anagram, you will have all zeros. Otherwise, you're going to have something that will sum up to 0, but it'll look like, you know, like this or something. And then basically all we need to do is essentially we're either going to have all zeros or we'll have a bunch of positive and negative numbers because they still need to add up to 0, right? So for every positive number, you need to have some, I mean, not for every positive number, but if you have some positive numbers, you'll have some negative numbers. So then essentially what we can do is we can just take a max here, and the max has to be 0 if it is an anagram. So you can just get this, right? Every single one, add 1 here for every single character, and then subtract 1 for all of these. So let's walk through that with this rat and car to see that. So for rat, for example, we'll have r equals 1, a equals 1, t equals 1. Then for c, we don't have a c, so we'll have c negative 1. Then we will subtract 1 from a, and then we'll subtract 1 from r. So you see, you're always going to have this kind of situation if they don't have an anagram, if they are the same length. So we can just check for length first. If the lengths are different, then there's no way. But if they're not, if they're the same, then we can do this kind of thing. Get the max key, and the max key has to be 0 because basically if there's a positive, there's a negative, and you can just check for that. So you just go through the keys, make sure they're all 0, and that's basically it. So that's how you do it with one dictionary. You could do two, and the nice thing about, so there's two really common ways I can think of checking for anagrams. One is this, right, letter counts. And the nice thing about this is we have a dictionary, especially here, I think it's only lowercase English letters. So there's only 26 characters, which means this is basically all one space, right? If there's only 26 characters, your word can be like a billion characters. You're still only going to have 26 in your dictionary, which is really nice, right? Because you have all one space here. Now the other one is sort the words. So you can like make them into an array and sort them. And basically what would happen is you take anagram, you would sort the letters, and then what would happen is your array would be like A, G, M, N, R, or N, R. Right, so if you sort the words, this sorted would be this, and this sorted would they be the exact same thing. Then you just sort the words, you compare character by character, because your anagram sorted, because they use exactly the same characters, should be exactly the same. So you just sort both of them, they should both be exactly this, then you just compare character by character. If there's ever a difference, you return false. But the problem with this, because like in Python and in most languages, you can't sort a string, so to sort it, you have to make an array, and then that would be O of n. So that's why this character count is a lot better, because also sorting is n log n, so it's n log n time, and we also have to have an array of every character. So that's why the character count is much better, and that's what we're going to go with. So let's code that up. And we're going to use a default dict in Python, because if a key doesn't exist in Python, it will give you a value. Now, you could use a normal dictionary, and you can just check like 4 letters in T. If it wasn't an S, then you can return false right away. So that's one thing you could do, but I'm just going to use a default dict. So personal preference here. Yeah, so we're going to say counts equals default dict, and it's going to be of type int. Then essentially we're going to loop through every character in S. So for character in S, counts of the character plus equals 1. That's the other thing. We don't have to check if it's in there. If it's not in there, it will just make it. So just easier. Then same thing for T. So for character in T, remember we're going to subtract because we're only going to use one dictionary. Like I said, you could totally use 2 different dictionaries, compare the keys, make sure both of the keys are the same, and make sure the counts are the same. Totally do that. Okay, so anyway, so counts character minus equals 1. Then we just remember we're going to have keys with counts. Oh, the other thing we forgot is we want to, if these 2 lengths are different, we can just return false. So if length S does not equal length T, we want to return false because there's no way they can be anagrams there. Return false. Then, yeah, so if this is the case, we want to subtract. Now we basically just return the max of the values in the dictionary, and every single value has to be 0 for it to be an anagram. So we can just say return counts values. And there we go. Now, slight Python optimization, and I did get told, so for these easy problems, I'm going to try to like break it down like this, because it's mostly for problems who are kind of new to DSA. So you could do this. Now, a Python one-liner you could do as well is Python has something called a counter, which literally makes a dictionary of letter counts for your string. So it will auto do that. So you can literally just say like return counter S equals counter T. And what's going to happen here is it will make a dictionary of letter counts for S and T. And if they are the same, it will be true. So this also works. So this works, and the other one works as well. So either, apparently not. Let's see. Apparently we did something wrong. Counts equals default dict. Oh, right, we never actually said it was 0, right? So max count values equals 0. There we go. Okay, so both of them work fine, but that's kind of the way you want to do it, and I think definitely sorting is going to be worse because, like I said, n log n time, and also you are storing an array, which will be n space. So here we have n time, and we have 1 space because, like I said, this dictionary only has lowercase English characters. So if they're saying like if it has Unicode characters, or let's say like for example, let's say our string was only like 20 characters, but we could have like 500 different types, then you'd want to sort it, right? Because then sorting wouldn't be so expensive, but you know, storing a bunch of different types of characters would be more expensive. So that's kind of yeah, I think and even then, honestly, maybe sorting wouldn't even be better, because then you're if you had like a string of 20 characters, you still only store 20 characters, so I'm not even sure about that one. But yeah, regardless, that's going to be all for this one, and if you did like this video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.